没好吃。
但是我感觉我来了也没
但是我在后面来。
对啊，这也是个问题。
还问你那个问题。
是的。
蛮像hungry人。对。Oh, there's a lot of Europe.
Really?
So do you surf like competitively?
I don't really
它其实是
6:30
的篮球比赛。对。
哦，
我
那
来了
晚点去。
但是我
I've never. I think I've surfed.
本领说不来。
Right.
可
Hello.
以直接选。
We are going to go ahead and get started. Quick show of hands, who was here last week? A couple of us. Okay, great. We're going to start with a little refresher on last week, so don't worry. The way that this is going to work, if you have not been to one of my workshops before, is that this is going to be pretty hands-on. This is going to feel a little bit more maybe like a lab. So I will kind of give some instructions. I'll give you some exercises, kind of like a worksheet, and then you'll have some time to work through them. I'll kind of float around, answer individual questions, and we'll go through the answers to sort of each piece as we go. So be ready to kind of like hands on keyboard. We're going to be writing a lot of queries today, get you guys to practice in writing SQL, which is our focus for today. We're going to do queries that are a little bit kind of like a half step above the queries we were writing last week. So a little above kind of our intro level queries. So yeah, hope you're excited. If you didn't already check your name off on the list when you came in, if you could just do that at some point before you leave, just helps us keep track. Okay, great. Just a couple of kind of like admin steps before we get started. If you were here last week, this will be familiar. We're using a tool called Hex, so you don't need to download anything to your computer. It all happens in your browser. You should go to this link, which is also at the bottom of all the slides and on the whiteboard there. Go to that link. That will give you a little button that has a link to sign up for Hex. It's this big complicated link, so I put it here so you wouldn't have to type it yourself. If you go to this link, it'll be there. And that'll give you a free account on Hex, which is the platform that we'll be using for all of the sessions in this series. So go ahead and get sorted out on doing that. If you joined last week, you're just going to go to the first part of this URL, this app.hex.tech, and just log back in. Make sure you use your USC email or USC like Google, Microsoft login. That'll make sure you get to the right spot. Okay. If anyone has any questions, you can't get in the link, whatever, give me a little wave. Okay, once you're in Hex, you're going to be looking for fall 2020. Week 2, this is sort of like our template for today. All right, so you're going to need to make your own copy that you can edit. So once you're in Hex, you should be looking for something that says fall 2025 week 2. If you don't see it, you can click on the left on projects. That might bring it up, depending on whether you've logged in before. And then you're just looking for this ... and then duplicate. All right, so I'll show you what that looks like. Fresh one here. All right, so I've got all kinds of stuff in mine, so I can see more stuff than you can, but you're looking for something like this, fall 2025 week 2. All right, and then you're looking for ... and then duplicate. You can give it your own name, like if I were to do ... duplicate here. Do that, and it'll generate a copy of this thing. It'll take a second to go, and I can name it something like Rachel's copy, so I know that it's mine. All right. Give everybody a moment to do that, and then we'll do a couple more things before we actually get in here. I also put the slides I'm going to be going through. If you like to also have them on your own screen, I put a link at the top of this. So if you'd like to have them on your screen, you can do that. All right, anyone have any issues finding this? Anyone have any issues getting their own copy? Give a little thumbs up if you got your own copy, just like it's working for people. Okay, cool. All right, you can take a moment to finish doing that because I'm going to talk for a little bit before we actually get into our data sets. Okay, fabulous. So where are we in sort of our series? So last week we covered an intro to SQL for our folks coming in totally new. Hopefully, if you didn't join us last week, you've at least seen a little bit of SQL before. If not, we can probably still get you through today, but you might expect a little bit steeper of a learning curve if you were not here last week. So today, like I said, we're going to be getting into sort of the next level of queries, and which is often referred to as data modeling. I'll explain what that means. And then just to give you an idea of what to expect for the next 3 weeks, next week, we're going to kind of put SQL on the back burner for a little bit and get into Python, which is another kind of complementary tool for analyzing data. We'll spend 2 weeks more focused on Python. And then in week 5, that last week right before Thanksgiving, we will kind of put everything together and give you all a chance to work on a little kind of portfolio project that combines some SQL, some Python, and a little bit of visualization from that data as well. So if you're interested, I encourage you to come all the way through to week 5 so you can get into the piece that you can have in your back pocket. Okay, so what we're going to do today is we're going to do a little bit of a review of what we covered last week, a little quick refresher on SQL in case you haven't been writing it for the 6 days since you were last here. Then we're going to get into data modeling, which is going to involve a lot of joining data frames together. All right, this is one of the things that makes SQL extremely powerful, is the ability to combine data sets and start to ask much more interesting questions of them that way. And we'll also, if we have time at the end, we'll talk a little bit about contrasting between data types, which is just another tool you can have in your pocket for combining data sets. All right. So we're going to get right into some review. If you're just joining us, make sure you go to this link and get logged into Hex for week 2. There's instructions on there to copy our week 2 template, which we'll be using. So just make sure you're making your own, hitting duplicate to make your own copy. Okay, so while some of you are still getting set up, we are going to do a little bit of a review. So what does a SQL query look like? Hopefully this looks a little bit familiar. Every single SQL query you're going to work with is going to start with the word select. All right, so at its most sort of base form, your query is going to be selecting some information from a table. All right, that's sort of our most basic form of query, or these top 2 lines. All these other pieces are a little bit like a menu. You may or may not add them depending on what you want to get out of your query. All right. So you can select a individual column, several columns, all your columns. You can perform a function on your columns, like taking a count or an average or a sum. Okay. You're going to tell your query what table you want to select this information from. Typically, you're going to be working with multiple different tables. We'll be doing that today. You can join other tables on. There's a couple different ways to do that. We'll do a bunch of practice of that today. We just sort of scratched the surface of that if you were here last week. Where, this is where you're going to give your conditions. You can think of these as your filters on your query, right? A where clause is typically going to reduce the size of your data set, your number of rows, because you're going to filter by some criteria. Is this a certain value? Is this value above or below a certain threshold? That kind of thing. Group by is going to give us the opportunity to summarize our data. So if we want to do a count by country, for example, or a sum by episode, those types of things, we're going to let our query know what we're counting or grouping or summarizing by. Order by is sorting. All right, so anytime we want our results sorted, we have some options that we can sort by any of our columns. And then we can always limit our results to a certain number of results. All right. This same little tidbit is in your Hex template as well. All right. So you'll be able to have this to refer to. Just as a reminder, you'll often by convention see these sort of keywords written in all caps, the select from, etc. I often don't write them in all caps. They work both ways. So totally up to your preference. Okay. So a little bit reminder, refresher on some of the queries we wrote last week. In last week's class, we were working with 2 data sets related to the TV show Seinfeld. All right, you can go back in Hex and look at week 1 if you missed it last week, if you want to take a look. But we had a data set on the transcripts of each episode, so each line of dialogue for each episode. And then we had another data set with rating information for each episode. So how is that episode rated by some sort of panel of reviewers? All right, so these are some of the queries that we wrote last week as a refresher. This very first query is an example of a query you're probably going to write every single time you start a new project that you're working with a new data set. Select star, star means everything, all the columns. Select star from this table, this is my table name, and just limit it to the first 20 rows or so. This is sort of the eyeballing query, right? You want to actually look at some sample rows of your data so that you understand what you're working with. As a little hint, we're going to write a couple of these queries in just a moment to sort of kick off our new project, to get to know our new data sets for this week. All right. So this is a very common query. You're going to write this a lot. Here is a slightly more advanced query that we worked on last week as well. All right, so here we're doing a couple things. We are selecting our character name. We are doing a count of all the rows related to that character. So all the rows where that character appears as their number of lines. So we're doing an alias here. As is just allowing us to retitle this column to something that'll make sense in our results. We're pulling this data from that same table, our transcripts data table here, and then we're adding a few components. All right, so from our little menu of options here that we can add, in this one, we are adding a group by, in this case, our character, because we want to summarize by character. All right, and then we're adding an order by because we want to sort our information. All right, so anytime you're grouping or order buying, I suppose, you're going to let the query know which column you want to group or order by. So you're just going to tell it that column name again. And then order by is always by default going to sort smallest to largest. Often in data, we want the other way, right? Because you want the top sort of numbers of things. In that case, you want to switch it. You want to have it go descending. You can give it DESC for descending. Okay. So this is one of the queries that we wrote last week that gets sort of a few more of these components in the mix beyond just our kind of basic select star. Okay. I think I have one more in here that we wrote last week, maybe 2 more. We'll just do a little bit more review. This is a query that we use where we start getting into some formulas. Okay. So in many ways, this query is quite similar to the last one. We're selecting some columns. We're doing a little alias here. We're doing a little group by here. All right, that should all look familiar. In our summary section, we're counting up some more columns with a specific case applied. All right, so in this case, we have our lines of dialogue. We have a row in our data set for each line of dialogue spoken by various characters. We want to know for each episode how many lines of dialogue each character had, but we don't want to totally filter them out of our whole data set. All right, meaning we didn't want to say where the character equals Elaine, because we still want to know how many total lines were in that episode, but we also want to be able to count specifically certain cases or certain scenarios within our data set. So that's where we're using our case statement. All right, this is where we were talking a little bit last week about how sometimes SQL can kind of sound like a weird robot sentence. All right, so it's a little strange, it's a little stilted, but it is pretty logical as to what it's doing. So this is saying count case when some condition. In this case, when the character is Elaine. Then what should you count? In this case, we're counting our dialogue column. So how many of these rows have the dialogue column filled in? And then end. That's it. That's just telling it that we have one sort of when, then, end. That's how our case statement is structured. And this will give us our number of lines spoken by Elaine. All right. So how this query would work, let's say there's 10 lines of dialogue in an episode and 2 are spoken by Elaine. our count dialog here, this first count will give us 10 as our result. And then our second case statement here, our count in this particular case will just count those two. All right, so our results table would look like season 1, episode 1, lines of dialogue 10, Elaine lines 2. All right, you can see why that might be helpful if we wanted to say, figure out what percentage of the time is a certain character speaking or that sort of thing. All right. So case statement is another formula that we went through, or one of the formulas that we went through last week. Okay. We've got one more query from last week that I wanted to talk about as a little review. All right. So as I mentioned, we sort of scratched the surface last week of joining data sets together. We're going to be doing a lot of that today because, again, that's where a lot of the power comes with SQL. So here's a little reminder of one of the joins that we did last time. Okay. We wanted to join our ratings data and our transcripts data together so we could start to do some analysis. Things like, are episodes more highly rated if a certain character has more or less lines, right? That's the type of analysis that you can do once you've joined those data sets together. In order to join data sets together, you have to have a key. A key meaning a column or columns that match in both of your data sets so that you can sort of overlap them. Okay. In this case, we wanted to make sure that our ratings data was summarized by season and episode number. So season 1, episode 1, season 3, episode 2, that kind of thing. And we also wanted to make sure that our transcript data was summarized by season and episode so that we could connect season 1, episode 1 over here. We'd go look in this data set for a row that had season 1, episode 1, and we'd use that as the key to connect our two data sets. All right. So that's what we're doing here in this query. We're doing select star, select everything from our ratings data set, which we've made here. We've already done some summarizing here. Join. So this is where we're doing our join. And then we're just putting a second query in parentheses. In this case, it's another very simple query, select star from this other data set over here. All right. And then we can use one of two keywords to connect our data sets. In this case, when the column names match in both, we can do using, and then we can give it one or more columns depending on what we need to match. In this case, we need both numbers because season is not sufficient, right? There's a bunch of episodes in each season. And also every season has an episode 1, 2, 3, right? So just knowing the episode number is not enough. We need to know both numbers in order to match the rows accurately, okay? So this is the join that we worked up to last week. All right. I know that might be a lot. I know we might be feeling a little rusty, either from last week or the last time you looked at some SQL. But hopefully you're starting to see some of the same keywords again, starting to remember sort of how this works. The other thing to remember about this is that when these terms do appear in your query, they're going to be in this order. All right, so your where is always going to be after your from, your order by will always be after your group by, etc. All right, this is your little menu and it always goes in order. Okay. So we're going to take a quick step back from that and pop over to Hex, make sure everybody knows how to get your way around in Hex. So if you haven't already, make sure you go to this link, which will get you logged in to Hex. Once you're in there, you'll make your own copy. If you're on fall 2025 week 2, just make sure you do the little arrow and duplicate, or if you find it in the list, you can do the ... and the duplicate, but just make sure you're doing duplicate here so that you get your own copy that you can edit, just your own private copy to work on your queries. Okay, anyone have any issues with this part? Everyone have their own copy? Feeling okay? Okay, great. All right, so as a reminder about navigating around in Hex, one of the most important things you're going to use a lot is up here on the left, this little lightning bolt, that's your data browser. All right, this is where you're going to find your data. Now, when you first hop into your data browser, you're not going to see our data. You're going to see some other demo data. That's because we need to run our project. All right, so the very first time you make your copy, you're going to need to hit this run all button on the upper right-hand side. that's going to run a tiny bit of code that I've sort of pre-populated for you. That'll bring in your data. You'll see as soon as that runs, you'll have a little section called in project data frames in your data browser. All right, so I'm in Hex, in my project, up on the left-hand side with my little lightning bolt icon. You're looking for something that says data frames. All right, if you don't see it, you got to hit the pink run all button up on the your left-hand corner. Okay. All right, once you have your data frames, you can click on them, and this is where you can see a bunch of information about the data that we have to work with. All right, so we've got data for this week. We're going to be working on data from the 2024 Paris Olympics. All right, so this is some of our data about the athletes and the results of those competitions. So I have a few data sets loaded in here for you already. Athletes data, medalists data, medals data, rowing results, volleyball results, and teams data. Okay. There are many, many more data sets if you download all of the results of the 2024 Olympics, but I pulled out a few for the purposes of this workshop. All right. So when you're in your data browser, you can click on any of your data tables and you can see all the different columns that are available to you in that table. Some of these tables are quite large, right? These tables have a lot of data going on. This one has 36 columns. I can do that for any of my data sets here. I've also got some empty data frames. Those don't have anything in them right now. That's where we're going to be writing our own queries shortly. Okay. All right, last thing to know about Hex is that you'll be adding cells as we go. Each cell or each sort of block in here is a cell. I've got blocks of text throughout here that are sort of little instructions or the exercises that we're going to work through. This very first block of code that you'll see is some Python code. We're actually not going to talk about this until next week. All right, so you can sort of ignore that for now. Just know that it's loading your data using some Python. But everything else we're going to do is to either add into or add additional cells for SQL. So if you see any blank cells like this that say type SQL, you can write your queries right in there. If you want to write some more drafts, so you're running into an error, troubleshooting, something like that, you can add cells anywhere in here by just hitting this plus button in between any of your boxes. You hit plus, it'll ask which kind of cell you want to add. Today, we're just adding SQL cells, this SQL button right here. And you can add as many of those as you want all the way down. Okay. Everybody in Hex, any questions about getting to this point? Everyone has a copy. Okay, sweet. All right. Great. And then the very last thing to remember is anytime you're writing a query in here, you're going to need to run it. You can run it with this little pink play button in that same cell. All right. So we are going to do our first little exercise before we get into data modeling. All right. So our first little exercise, I have these organized here and numbered. So we're going to do our task number 1. We're going to start by looking at 2 of our data sets. I've got 5 or 6 different ones in here for us, right? Which you can see in your data browser. But we're going to start just looking at 2. We're going to look at the athletes data set and our medalists data set. All right. We know that every medalist is also an athlete, but not every athlete is a medalist, right? So these data sets sort of conceptually overlap a little bit, but they contain different information. But first, we're going to look at them separately. So just as a little warm up, your first task is to write a query to get the first 10 rows of each of these data sets. Okay, this is going to be a very simple query. We want everything, select star. And the other thing to remember about Hex is you're going to need to write each query in its own cell. So each cell should basically only say select one time. All right. So we're going to have a query to get the first 10 rows of our athletes data set, a query to get the first 10 rows of our medalists data set. And we'll also do a query just to count the number of rows in each of those data sets. Right. So to do that, You're just gonna come into your SQL cell down here and you're gonna type your query. This query is going to look very similar to the first query we wrote in our last section. In that version, we did select star from our table, limit however many rows you'd like to see, 5, 10, 20, something like that is usually enough to get a feel. And you can double check the names of your tables in your data browser up here. So that's where you're going to find exactly how to spell your table name. Make sure to get these underscores in there so that it matches exactly, right? Should look something like this. All right, hopefully you're had a chance to give this a little bit of a try. We're gonna come in here. You should be writing something like select star from. You can either write your query all on one line or you can separate it with new lines, up to you. If it's pretty short, I often keep it on one line. So in this case, I want to look at my athletes data set. How do I know what data set that is? I'm going to come to my data browser up here and just double check how it's spelled. All right, here it's athletes underscore data. Type it that same way here. And you'll see once I start typing a table name, it'll give me a little suggested autocomplete. Very handy. And maybe I just want to see the first 10 rows or so. Once I have that, I'm going to hit my little run button, this little play icon in the corner of that cell. You can also hit Command Enter on your keyboard and that'll do the same thing. All right, select star from athletes data, limit 10, and this will give you immediately just below those 10 rows. So next thing you should do is sort of scroll across and take a look at what data we have available to us. There's a bunch of columns here. Looks like we've got some sort of code, we've got name, gender, country, nationality. Looks like we have height and weight for many folks, although it's also 0 for a lot of folks, right? So some incomplete data. We have the disciplines that they're participating in, the specific events even. Birthday, birth country, residence, nickname, hobbies, occupation, education, language, coach, influence, philosophy, their hero, right? We've got all kinds of data. Some of it, a lot of them have blanks or zeros, so it's not the most complete data set, but we've got text data, we've got numerical data, we've got some dates, got a lot of different formats of data going on here. Okay. All right, next thing we're going to do is the same for our medalist data set. All right, we want to get familiar, just sort of get some mental context going on for what that data set is. We're going to do the same thing, select star from medalist data, and I'm going to limit that to my first 10 rows. All right, I'm doing this in another cell. If you need another cell, you can hit your little plus button there. Right, my query, I'll run that and take a look at my medal data. All right, this one also has a bunch of columns. It has a date. It has whether it's gold, silver, or bronze. It also has a medal code. Now, I don't know exactly what a medal code is, but just looking at my eyeballs here, looks like it goes gold, silver, bronze, and then 1, 2, 3, and then sort of repeats that pattern over again. Okay, so gold, silver, bronze, 1, 2, 3, 1, 2, 3. So looks like medal code 1 probably equals gold. It's probably like a numerical representation. This kind of thing is why it's good to look at your data with your eyeballs like this before you start doing any sums or averages or anything like that. So you can get some context for things like this. Oftentimes your data set will come with some amount of documentation that might tell you sort of these sorts of things, but it also might not. So it's good to take a look. Looks like we've got a little bit of information about those medalists, name, gender, country, etc. Maybe some of the same information, whether or not it's a team, what discipline it's in, birth date, code athlete. All right, so some sort of number representing our athlete. And then this column that says is medalist. Looks like that might just say true for everyone. That sort of makes sense, right? If I look at my data browser, my medalist data set has about 2,000 rows, and my athletes data set has about 11,000 rows. All right, so about 2,000 of the 11,000 athletes that go to the Olympics go home with some sort of medal. That makes sense, right? I expect there to be fewer medalists. So it looks like this column probably just is true for everyone in this data set. Okay. All right. So the other reason you're looking at these data sets sort of with your eyeballs is you want to look at what pieces of data are the same between these two data sets. Specifically, what pieces of data might you use if you want to link these two together? Okay. So why would I want to link these data sets together? All kinds of reasons, especially things like if you want to know for each country what % of their competitors came home with a medal, right? You would need some information from this medalist data set, meaning you need to know who actually won a medal, but you also are going to need the denominator to get that percentage, right? You need to know the total number of athletes from each country, so you need both of these data sets. One of many examples of the type of question we can answer if we combine data sets. All right. Now we have a lot of overlapping columns between these two data sets. We have name, nationality, birth date, sport, discipline, right? We've got a lot of similar columns, but specifically one that caught my eye in our medalist data set is this one over here towards the end, which says code underscore athlete. All right, this one looks like they're all these kind of 7 different numbers. And looks like they are, I'm not seeing any repeats, right? So I could check this, but I'm getting a sense that this is probably a different distinct number for each athlete. If I go back up to my athletes data set, I'm going to see a column called code. And if I look at these are also 7-digit numbers, right? And it also looks like they're going to be different for each athlete. Again, I could verify that with my documentation or with another query. All right, but I'm getting a sense that each athlete is assigned a code. That's sort of a unique identifier that I might be able to use to match an athlete from this data set to that athlete if they appear in our medalist data set. All right. Now, why do I care about the code when we also have their name, we also have their birth date, right? We have other things we could use to connect them. And that's true, those other things might work fine. Typically, when you're looking for columns that overlap, we're looking for something that's unlikely to be typoed. Okay, so something like an ID number or an email address, something like a name. You can, you know, William and Bill, right? You can get different things, different typos, different versions of a name. May include a middle name, may not, etc. So even if you have a column like name that's the same between multiple data sets, you're really looking for something that's going to be sort of a true unique identifier. So something like an ID number is great and looks like we have that here. All right, so file that away. We're going to be using that in a little bit. Did everybody get these two queries to run? Our select star from athletes data, select star from medalist data. Anybody not get a little table to appear like I've got here on the screen? All right. Next thing we're going to do is the second part of our first task here is to check the number of rows in our athletes and medalists data set. Technically, we don't fully need to do this because Hex is going to tell us that itself, but it's a good thing to practice, and we're going to be using count again later. So this will give you a little chance to practice using our count function. All right, so we want to count the number of rows in our athletes data set, and we want to count the number of rows in our medalists data set. All right, so those are two different queries. They should each return a whole number. And if we go back and look at some of our queries that we wrote in our last week, we've got some examples of counting in here. In this case, we're counting with a group, which we don't need. We just need an even simpler count to do sort of a quick look at our data set. but we want to select the count of everything from our athletes data and the count of everything from our medalist data to just check that number of rows, make sure it makes sense to us. Right, so go ahead and give that a try. Your result should be a single number instead of a table of rows. All right, so hopefully you have something like this. I'm always starting with select. In this case, I'm going to do count star instead of just selecting star because I want the count of rows. I don't want all the rows themselves. All right, and then from same tables I looked at earlier. So I'll start with athletes data. All right, so you should have select count star from athletes data. That's our super simple query that'll just tell us our number of rows. All right, it's just going to give me this one little result with a number. That's how many rows are in my athletes data set. And I can double check that against my data browser right here. I see the same thing, 11,113 rows in both cases. I'm rocking and rolling. And I can do the same for my other data set. All right, so we're going to start with our athletes and medalists data set. So I'll select star here. In this case, I'm seeing 2,315. All right, and that should match my number in my data browser. Right here, my 2,315 medalists. Right. Cool. All right. Anybody have any errors? Anybody able to get your count star queries working so far? Feeling good. Okay, great. Hopefully you're starting to feel a little bit warmed up. All right. So the rest of what we're going to do today, that was sort of some data exploration. The rest of what we're going to do today is closer to data modeling. So what is data modeling? Data modeling, first off, is something I do at my day job pretty much every day. And data modeling is essentially a set of SQL queries that cleans up your source data. So you're making it easier to ask and answer questions of that data, the types of things that a business user or an end user, someone who's a little bit less technical, might care about. All right. So your initial data sets, in this case, the data sets that we're working with are source data. So this is something that you might download from the database or export from some sort of system, or you sent out like a survey or a form and a bunch of people fill it out and you get the results, right? That's your source data. It can be a little messy, right? So we already saw in our athletes data that we've had columns for height and weight of our athletes, but that those columns were 0 for a lot of people, right? That's not because this person is 0 inches tall, that's because that's missing data, right? So that's a type of thing that can be a little messy in your source data. So what you're looking to do with your data models is to take that source data, do any joins or formulas or things that someone might commonly need to do for their queries so that you have it kind of ready to go. So you're basically getting it all nice and cleaned up so that if someone wants to ask a quick question, it can be answered with a quick query instead of a more complicated one. Okay. So let's look at an example of data modeling. A very common piece of information or a metric you might care about as a student is your grade point average, right? Your GPA. How do we get to your GPA as a student? Let's say the university database. All right, how do they figure out your GPA? They store a bunch of different pieces of information about you. So probably in the database looks something like this. This left-hand column right here, they have some table that's just every student, your name, your hometown, your student ID number, your email, all that kind of stuff. They're going to have enrollment, right? So they're going to have for every semester, for every course, every student, who's in it and what letter grade did they get, right? So there's sort of a row with those 4 pieces of information for every class you take every semester, multiplied by every student, every class, every semester over time, right? So there's going to be a lot more enrollment rows than student rows, right? And then the university also has, probably somewhere at the registrar's office, a little table that says an A is a 4.0 and a B is a 3.0 and a B plus is a 3.7 or whatever the numbers are, right? So there's some table that exists university-wide that tells you, right, what letter corresponds to what out of 4 so that they can get you a GPA on a scale of 4. I assume it's 4 here, it's 5 at some universities, but either way, same principle applies. So if you're a student and you go to your online portal or whatever, and you want to pull up your GPA, the system or the person working there or whatever is not going to want to start from all 3 of these tables and filter all your information down and double check the letter grade against the table to calculate out your numerical grade point average, right? You don't want to do that set of steps every time you want someone's GPA. Instead, you want to summarize sort of by student, how many classes did the student take? What are the numerical grades that correspond to their grades in each of those classes? And what is the average of all of those numerical grades? AKA, what is your grade point average, right? So there's sort of like a couple of steps between how the data is stored in a database, in a system like this, and the database that you, the sort of like end user or sort of client, or however you want to think of it, wants to get. So data modeling is the step in the middle where we're sort of doing any translation or joining together. So we have this ready to go. So when you ask for your GPA, all we're doing is we're just filtering by your student ID number here. We're not doing these 4 other steps in the middle. So why do we do data modeling? A very common situation, if you are the person working with the data or working with the database, you might get a question from someone. I get this sort of thing at work all the time. Hey, can you just quickly pull the sales numbers from last quarter compared to the same quarter the previous year? Typically, someone asking that question is just assuming that I have a list of sales by quarter and I can just go and pull those real quick and provide the answer in a matter of seconds, right? Now, I might have that if I've already done the data modeling work to make a summary by quarter for each of the things. If I haven't done that yet, it's going to take me a few steps. I'm going to have to clean out anything that was a 0 or a negative number or something that was misentered, right? So it's going to take me a bunch of time to answer what sort of an end user might think is a quite simple question, okay? So this is what we're trying to accomplish with data modeling, is kind of get our data into a state where sort of common questions, simple questions have simple answers, right? Okay, so a lot of what we're going to be doing with our data modeling is joining together. As we saw in this example, there's a lot of cases where something simple like a GPA is actually coming from a few different sources of data. So one of the biggest things that we're doing with data modeling is joining, right? Again, we played with joins a little bit last week when I was talking about joining our ratings data and our transcripts data together. For the purposes of today and most common uses of SQL, there's kind of 2 types of joins you need to worry about. One is a regular join and one is a left join. The reason we're not talking about a right join, which technically exists, is because in practice, the vast majority of the time you're going to use a left join. Okay? The difference between these 2 types of joins, you can think of these as a Venn diagram. All right, let's say I have all of my athletes data in one data set, all of my medalists data in another data set. The sort of Venn diagram of those two where they overlap are those athletes who appear in both, right? Everyone who actually earned a medal. If I want my results to have only people who appear in sort of both sides of my Venn diagram, I'm going to use a regular join. It's just going to look for everything that has matching values. And if it doesn't match, so if you're an athlete who didn't win a medal, you're not in the medalist data set, it's going to drop you out. Okay. So it's going to join together. It's going to look for you in the left, look for you in the right. If you exist in both, it'll include you in the results. If you're missing in either of them, it's not going to include you. Okay. Sometimes this is helpful, depending on your context. Sometimes you're going to want to keep all of the rows, even if they don't exist in the other data frame. This is called a left join, meaning you start with some data set on the left and you're sort of augmenting. If that value, your key also appears in your right-hand data set, you'll add that information on. If it doesn't, that's fine. You'll keep that initial piece of information, the initial sort of row from your left table. It'll just be blank on the right-hand side. All right, so this is what we might want to do if we have all of our athletes' data on the left and we want to add on information about anyone who earned a medal. We don't want to drop anyone who didn't. All right, in that case, we would use a left join, where we've got our athletes' data on the left-hand side, and we would join on our medalist data. So if you got a medal, we've added some information about it. If not, there's just some blanks going across your row where the medal information would be if you won. Okay, does that sort of conceptually make sense? I think we'll work through some examples, but that's sort of the mental model to have in mind. Okay. All right, so I think within the sort of most common question I see from students about joining data together is not sort of the technical writing of the query, right? As you saw before in our example from last week, this query is actually like fairly simple. It's not super long. It's like pretty straightforward with what we're doing. So typically with joining, the problem is not writing a long, complicated query. It's making sure that conceptually you've got the right pieces together. All right. So in an effort to help you kind of learn how to think through that, I've written out sort of like a little checklist you can go through for yourself when you're thinking about joining two data sets together. So we're going to go through this as a few practice exercises today. Okay. So first things you need to figure out are where are the columns that you need? What table do they live in? If all the columns that you need in your sort of end result, if all that information lives in the same table, you don't have to join anything. If it's already all in one table, great. You're just writing a super simple query, no join required. All right. But if the columns you need are in multiple tables, you are going to need a join. So first thing you want to do is start writing some simple queries, select whatever columns from whatever tables, and figure out where all your columns live. All right, that's your very first step. When I'm doing this step, I'm often writing a few different sort of draft queries for myself, just grabbing the columns that I need, making sure the data looks like I expect it would look. Okay, that's step one. Step two is to figure out if your rows will match, if each row is sort of one entity. What does that mean? This means that your rows should be sort of counting the same type of thing. If each row is a person in one table, each row should also be information about just one person on the other side. If we have a table that's information about individual athletes over here, and we have a table over here that is information about each team, that's a sort of a different entity, right? A team is different than a person. So joining them together is not going to make logical sense until they're the same entity. I could do something like take all the athletes and group them by their team, right? I could summarize, take the average age by team, for example, or count the number of them in the team, right? If I do some sort of summary so that conceptually over here, each row is a team, then I'm all set to join it on my other data set where each row is already a team. Does that make sense? So you should have like a person and a person, or a team and a team, or an episode and an episode, right? You got to kind of make your entity the same. And if they're not the same, you probably need to summarize your larger data set so that your entities are lined up. All right, that's your second step. Third step is to figure out if you need the rows that appear in both tables. This is the left and right join I was just talking about, right? Do you only want information about people who won the medal, or do you want information about all your athletes plus medal info if they happened to win a medal. All right, that will tell you if you need a join or a left join. Okay. So that's your third step. Your fourth step, we sort of had a little bit of a preview when I was talking about our athlete code, right? For all the tables you need, what column do those tables all have in common? What's a key you could look at across all of those to join them together? So in this case, we already identified that our medalist table has that athlete code, which exists in our athlete table. It's called code, but it's conceptually the same thing. So it has that overlapping column, that unique identifier. That's what you'll use to bring your, to have your join sort of look up on that key, right? This can look one of two ways in your query. If the column title is literally this, like spelled the same in both your tables, you can do using and just put that shared name in parentheses. If the name's a little different, right, which we already saw in our data set here, it was athlete code in this, or code athlete here, and just code here. So if those column names are a little different, I'm going to do on name, column 1 equals column 2. I'm just going to tell them that those things are equal, and it'll do the join on them, even if they're labeled a little different. Okay. That's my fourth step. And then my very last step is just confirming what columns I want to end up with. Do I need any formulas? Do I need a average or a count or a sum, a case statement, any of those other formulas that we've talked about? So these are kind of the 5 steps that I go through kind of mentally when I'm thinking about joining 2 data sets together. So this is the little framework you're going to use as we start working on some joins. All right. I put this in here as a little reference. We talked about a bunch of these last week. Your where condition or your case statement, anytime you're using some criteria, we have a bunch of different options for depending on the types of data that we're comparing. So I put a few common ones here as a little reference sheet. If we're comparing 2 numbers, we can check whether they're equal, not equal, less than, greater than, all right, just like math class. And if we're dealing with any sort of text data, or it's sometimes called a string of data, same thing. We can check if 2 pieces of text are equal or not equal. We can check if a piece of text appears in a list using in like this. And we can also check if 2 pieces of text match either case sensitive or insensitive. That's what these examples are. All right, so like this exact text, all right, will be case sensitive. I like is standing for insensitive, meaning it'll check for this phrase whether or not it's capitalized. And these little percent signs here will check for that phrase whether or not there's other text around it as well. If it's in the middle of a sentence, this will still count it as a match. Okay. So it's a little reference for some examples of what you can use in your where conditions or the when part of your case statement. Okay. All right. So with that, we are going to hop to our second exercise in your worksheet. All right, which is just a little bit down here. We are going to try to figure out what percentage of rowers who competed at the Olympics received a medal. All right, what percentage of rowers who competed at the Olympics received a medal? In order to answer this question, figure out how to write our query from this question, we're going to kind of break it down in these steps that I just mentioned. All right. So first step is what tables have the columns that we need. Okay. Now we're sort of like cheating a little bit here because we've already looked at the data. We've already done some previews. So we can already tell you that the athletes and the medalist data set have the data that we need, right? We need information on who all competed. That's going to be in our athletes data set. And we need information on who all actually got a medal. That's going to be in our medalist data set. All right. So something that I might want to do first is try to answer some of these questions separately, right? So I'm trying to break the question down into smaller pieces. Anytime I need a percentage, I'm going to need my numerator, my upper value, and my denominator, okay, my total value. So how many, I'm gonna need to know for the bottom of my percentage, how many rowers overall competed in the Olympics, and then how many of them received a medal. All right, so what I might do is start with writing those as separate queries. So 2 separate cells, just to get things rolling. And then I would think about how to join them together. What column should I use to join those 2 tables together? So to come to my little steps here, I know which 2 tables I need. Does each table have 1 row per entity? In this case, yes, right? Each row in my athletes data set is a person. Each row in my medalist data set is also a person. Great, I'm good. Do I only need rows that appear in both tables, or do I need all the rows from one table? What do you think for this example? Do I need all my rows in both tables? Or all my rows as long as they're just in one table? Meaning, do I only want a row that appears in both my athletes data and my medalist data? Or do I want, if that row just appears in the athlete data and not my medalist data? Is that okay for this question? Is that what I want? If my end goal is to find the percentage of rowers who earned a medal.
Only medal.
Only medal. All right, so if I did a regular join, which is here, if I did a regular join, that means that all rows from both sides have got to have matching values. Okay, meaning that if anybody in the athlete side doesn't have a medal, I'm going to drop them out. I'm not going to count them. If I did that type of join here, that would mean that my percentage result from that data set will be 100%, meaning 100% of the people in my result will have a medal because I dropped anybody who didn't by doing a regular join. So it's actually not what I want to do in this case, because I want my percentage, the sort of denominator of my percentage, to be all the people who competed. So all the people who, whether or not they appear in my other data set. And then my sort of math is going to tell me what percentage of those people, since we've looked at the size of our 2 data sets. Here we know about 2,000 people got a medal out of about 11,000 competitors. So I'm expecting about 10% of these people to have gotten a medal. So in this case, I'm going to want to do a left join. So I'm going to want to join my medalists onto my athletes data with a left join so that I still have all that data about the folks who didn't earn a medal. All right. Very good. All right. So I know I'm going to need to use a left join. All right. Next thing on my checklist is, what is that column that has is this sort of my unique identifier that I can match? We already talked about this. This is my athlete code. All right. Those columns have slightly different, they're labeled slightly differently. So I'm going to need to do something like on code equals code athlete here to get my join to work. And then am I going to need any formulas at the end? Probably, right? I'm going to need a formula to get my percentage. I could count up all my rowers that competed. I can count up all my rowers that earned a medal. And then I'm going to want to do a formula, a little division, right, to get my percentage of what percentage of them won a medal. Right, so we're doing a little bit of math. All right, so that's my checklist. Now that I've run through my checklist, how do I turn that into a query? Let's start with this. I'm going to grab some of my medalist data. All right, this is similar to what we did before. I'm going to take a look. I'm definitely going to want my code athlete here. And it might be handy to be able to use my is medalist sort of checkbox here. Those are 2 pieces that are looking helpful. So I might start by spelling out those columns. All right, if I run this just here, That'll give me just those two columns from my data set. As I'm sort of working through this, I'm going to think about the columns I need from my other data set as well. So what columns I need from my athletes data set. All right, so I might start with something like this. Like we already wrote, okay. And I'm going to start thinking about which of these columns I want. I definitely want that code, right? Because I've already identified I want to use that to match between my two data sets. And then I'm going to need some sort of column that will tell me what sport. How do I know of all these people who is a rower? All right. So in order to figure out who all is a rower, I need to know which column that lives in, and then how to filter that down. So I'm going to kind of go across and look at which of these columns tell me any information about their sport. All right, in this case, it looks like this disciplines column looks kind of promising. There's a few different ways I could do this, but one is I can just sort of scroll and look, right? I see wrestling, judo, triathlon, swimming, weightlifting, swimming, boxing, athletics. I'm looking for anything that looks like rowing. Aha, right below sailing, I have a couple folks where their discipline is listed as rowing in brackets like this. All right, so I know I'm going to need, that tells me that I know I'm going to need this column, this disciplines column, in order to get to my final result. I'm going to add that to my list of columns that I want. All right. So I grabbed my kind of columns that, as far as I can tell, are the columns I'm going to need. I've checked that I have my tables have one row per entity. Perfect. I decided that I need all my athlete rows, whether or not they appear in MetaList, which means I'm going to need a left join. All right. And do I have a unique identifier? I do. It's that code. All right. So I've got some building blocks here. I've got two kind of partial queries, and I know I'm going to want to join them. So I'm going to start a new cell down here. This is often how I write queries. I'm kind of doing them piecemeal, kind of in different steps in different cells, so I can kind of check the results as I go. I'm going to copy my athletes data set here, or my athletes query down here that I wrote already. I'm going to add on left join, since I already decided based on my little checklist that I need a left join. All right, what am I joining on the left? In parentheses, I'm going to put that whole query that I wrote for my MetaList data, right? I'm taking all my athletes on the side and I'm adding on the columns I identified from my MetaList data. I'm going to bring these on down. Right. And I'm going to put that inside my left join. So inside these parentheses after my left join, I have this whole other query. Commonly, these are sort of indented like this, so you can see what all is in this data. You can space it however you like, but commonly it's sort of indented something like this, so that you can sort of see what all is inside of that parentheses, which is just that other query that we wrote. Okay. So first query I wrote, left join. Other query I wrote is inside those parentheses. I'm gonna go back to my checklist here. So now I need to tell it that unique identifier column, right? What am I going to use to match my records? So since I know my column names are a little different, I'm going to need to use on. All right, so left join on or left join using. In this case, I'm going to need my left join on. All right, so here I'm going to add on. And then I'm going to give it my column names. I'm going to scroll, I can scroll back up, or in this case, I can just look since I've already parsed them out here. On code equals code athlete. All right, so this is me telling SQL, giving the instruction that if you see a code in this column called code, and you see that same numerical code in this column code athlete, that's the same athlete. You should join those two rows together. You should stick them together like this. Right. Okay. It's always when writing a query, as soon as you have sort of like a partial idea, you should try to run it and make sure that it works, right? See if you hit any sort of error messages. So far, this is looking pretty good. Got a couple more things that I need to do to get to my final result. So I'm getting closer. I've joined my two data sets together, but my questions here are about rowing, right? I need to narrow my data set down to my rowers, and the information about whether they're a rower is in this disciplines column. So I'm going to use what you always use for filtering. I'm going to use a where statement here. And I'm looking to apply some filters based on my discipline column. Basically, where disciplines contains the word rowing, I want to count that person as a rower. So I'll go back to my little reference sheet here, things I can use in where conditions. In this case, I'm probably going to want to use this phrase, this either like this text or I like this text, just so I don't have to spell it all out with the brackets like how I saw it is in the data source, right? Since it's spelled out like this, it's a little bit of a pain to type that extra stuff. All right, so I'm going to do something like this, disciplines I like. So case insensitive, just in case it seems like this data set might have some data quality challenges. And then I'm going to do rowing. All right. Anytime I'm giving SQL something I want it to read as a string or piece of text, I'm doing it in those single quotes. All right, so I'm putting rowing in those single quotes. And I'm also going to do my little percentage signs, which is what allows me to find it at any point in the sentence. So let's say someone's doing rowing and rock climbing and triathlon. So their disciplines thing has a bunch of text listed together, right? They're doing multiple sports. I will pull anyone who has rowing listed as one of their sports, regardless of what order it's in. Right, so just simplifies for me a little bit. I don't have to worry whether they're doing multiple sports or not. As long as I'm filtering with something like this, I should be able to get them all down. All right, so I'm going to give that a run. And I noticed, so in my little preview in my cell, it tells me how many rows I had. Before I had 11,000 rows. Now I'm down to about 500. All right, that makes sense. Rowing is not a huge Olympic sport, so I might expect to have a smaller number. So this is looking pretty good so far. All right. Now I'm going to come back to my checklist here, and I want to think about what columns I need to end up with and make sure those are all appearing in my results. All right. So let me go take a look at my results. So far, I've just got my code and my discipline, but what I really want to show up here is that count of rowers, right? I want to know how many do I have total? I know from my little preview here that it's 497. How many do I have total and how many are going to be medalists? All right. So I'm going to start with a count star, right? I want to know my full count. What's sort of the denominator of my percentage? That's the column I want to end up with. So again, I've kind of worked my way through my checklist. I've got my join, and now I'm down here, right? I'm trying to sort of finesse my final results. So I'll give that a whirl, see what that gets me, make sure that works. Great, this is getting me 497. This is a good moment to use an alias. So I'm gonna give this column a name that's more straightforward. So I'm gonna say as, give it whatever name I like, as long as it has no spaces. So I might say that this is something like all rowers. Just run that again and it'll update my little title of my column right there. All right, so I've counted all my rowers. Next piece of information I need to get my percentage is a count of all my medalists, right? Count of all my medalists. So I want to count something else, but I only want to count if they're a medalist. I want to count them in a certain case. So I'm going to use my case statement again. All right, case statement is the thing we used up here in our previous example. So case when some condition, then what should you count? End. All right, that's my little format for a case statement. So I'm going to come in here and set up my case statement. Case when, then end. I usually write that all out so I remember to include all those little keywords. And then I'm going to do my little alias as something like number medalists. Okay. So in this case, I want to count when they are a medalist, which is, I've got this handy column already that says is medalist, which is just going to be true if they're a medalist and blank otherwise, right? Since I'm doing my left join. So thankfully, all I need to count in my when is case when is medalist, then count them. Otherwise, it's not going to count them, which is perfect. Then I just need to give it something to count, basically some row that's going to be filled out on everybody. In this case, I know that my code row is filled out for everybody since that's my unique identifier, but I could give any column that's sort of filled out for everybody there. All right. And that should give me my number of medalists. All right, let's give that a whirl. And we've got an error. All right, let's double check what my error message says. Syntax error at or near count. Maybe some of you have seen this error. I definitely know some of you saw it last week. Anytime we're adding a column into our query, we need a comma in between, right? And all of our columns need a comma in between, which can be easy to forget when you start writing a bit of a longer function as I did here. I'm going to add in that comma, give it a whirl, and now I've got my two columns. All right, all my rowers and then my number of medalists. I'm just doing a gut check at this step. This number should be smaller than this number. We're looking pretty good so far. I'm getting 144 medalists. Okay, we are so very close to getting to our percentage. We have our top number, we have our bottom number. Very last thing we need to do is just a little bit of math. In this case, we just need to divide our number of medalists by our number of rowers and give that column a name. I'll call this something like percent medalists. Doing a little math. And I should get, I can sort of check with my brain, this should be, you know, like a third-ish, and it's 28.28, which is 28%. It's looking pretty good. Last thing I can do is a little sort of hex thing. If I want this to appear as a percentage, I can click on my new little column right here and hit this format button, which will let me format it as a percentage. So this is just sort of a nice little finishing touch. But I can click on this column, format, and then choose percent from list. Do something like this. And that'll make it a nice little handy 28.97%. All right. Yeah, question. Let's start here in the open here.
Can you explain the case when then?
All right, so a case statement is always going to have this case when then end. Those are sort of the keywords. That's the structure. You're going to have those every single time. The pieces you need to fill in every time you use it are after the when. So what's your condition? And then what do you do when that condition's true? Okay.
Okay.
So in this case, I'm saying check whether the column is medalist is true. It's only going to be true if they were existed in that medalist table. For everybody else, it's going to be blank since we did the left join. So just in that case, if that's true, then we're counting. This is happening within a count. So what should I count? Just some row that's not blank. So some like column that's not going to be blank for that row. So in this case, I know this column's filled out for everybody. So I'm just giving it code, but this column is not that important. It needs to be something that's not blank. And what this is going to do is if this person is not a medalist, it's going to not count them. Right, so it's going to count first person's a medalist. Yes, that's 1. Second person is a medalist. That's 2. Great, third person not a medalist. Moving on to the fourth person. Fourth person is a medalist. Now our count at 3, even though we're at 4 rows down. And it's going to do that sort of calculation all the way down.
What is that code?
What is
The code?
code? Is the name of the column.
Oh,
So I just need to give it a column name that's not blank.
Oh.
So in this case, you typically just want to give it like your identifier column. In this case, it's code, but I could have done code. I could have done anything else. Let's see. It looks like name is filled out for everyone. So I could switch this for name like this, and hopefully if no one's name is blank, this would give me the same numbers. Yeah, looks like that gave me the
Oh.
same numbers. Yes.
So I guess like in the final result, like how did it work when you got rid of select the column names?
Great question. So because I wanted to condense my final, in this case, I was trying to get to a percentage, I was trying to get to a summary. I didn't want to still have a row for each athlete the way I did before, right? So the reason I included those columns initially was for my little kind of mental checklist of, am I joining the right tables together? Do I have, here we go, am I joining my right tables together? Do I have what I need? It's very helpful to do that in sort of your intermediate query writing step. But once you get to the very end here of what columns do you actually want to end up with, what sort of level of summary do you want to end up with, at that point I realized I don't want a row for each athlete at the end, I just want that count. So at that point I want to sort of remove them from my final result.
So how come in the initial one when we saw all the rows, like the code athlete and is medalist rows didn't show up either?
That's because we did not list them at the beginning. So let me go back to that step. So we did this query here, and then we did our left join of our other query, left join. We did our medalist data. So let me grab this again. Great, and then we did on code equals code athlete, something like this. Let's see if I spelled all that right. Okay, great. So this is the same intermediate step we were at before. This is because joining column names on here doesn't make them appear in your final result. The only things that are going to appear in your final result are just listed in your main select. So if I wanted code athlete and is medalist to show up here, I would have to list them again in the first part of my select statement. So they're here sort of in my database, like in my table, in that I can access them, which we saw when we went and did the counts. But if I want to actually see them displayed here, I would have to sort of add them to my display list. I can do this. Hopefully I spelled those correctly. Great. And then I can see, and this is actually a great sort of visual check. I can make sure that code and code athlete always match so that my join worked as intended.
So you're able to do that even though you don't write medalist data in the beginning.
Yep. Yep, exactly. Yeah, the join works whether or not you choose to display the columns that you've joined. Okay, any other questions about what we did here? Did I see a hand in the back? Okay. Yeah.
I might miss something, but how does the line really just select the rowers every night?
It's just the rowers instead of every medalist. I'm doing that with my where statement. So where disciplines is I like this rowing. This where, though it's at the bottom, applies to everything above it. So that's filtering down. All the way down. Yeah. Any other questions about how we got here? And anyone get any error messages?
I think something shows that center arrow at or near rowers.
At or near rowers. Okay, what that might mean, so you should look for where it says rowers in your query. Common syntax error is forgetting a comma or a parentheses. So I would double check for anything missing. So anytime you get that syntax error, it should tell you near something. You should go look for that. It might not actually be on the same line, but did you find a comma or parentheses or anything?
Yeah.
Did that solve it?
Yeah.
Sweet. Okay, awesome. Any other error messages? Anything else? Okay. Cool. So I know that maybe felt like a lot of steps to get to this one little number as a result, but this is why we do data modeling. So in this case, we were looking specifically for rowers, but we could have done this table without our rower line. So in this case, I'm just going to do 2 dashes, which is going to make this into a comment, meaning it's not going to be executed. All right, if I do that and I run this guy again, it'll expand out to so it's not filtering out my rowers, it's getting everybody here. I could also have done this for every sport. So there's a cleaner way to do this, but just as an example, I can do this, which is going to take my same query. I can group I got rid of my account, typing too quickly. So I can take the same sort of query structure that we did a moment ago. Oh my gosh, group by one, okay. It's gonna think for a second. All right, great. And this is gonna do sort of the same logic that I did, but it's gonna do it for every sport, not just rowing. Okay, so this would be an example of a data model where if I had already made this table, if I had already done this joining, and somebody asked me what percent of rowers win a medal, all I would need to do is pop in here and just do select star from this for rowing, right? Because this is already all done. That's a much faster way to answer that quick question than going through this whole checklist of steps like we just did, right? So this is why data modeling is valuable. If I'd already done this work, if I'd sort of anticipated that percent of winners is a question that a lot of, say, sports journalists might ask me, if I'd already done this, it's a lot easier to just grab. Yeah. Yes, good question. Okay, so all I did with my same query, I should have kept a copy of it from before, but all I did is I added my disciplines up here because I wanted my result to have one row for each discipline. And then my group by here is going to tell my query what to group by. I can give it instructions in one of two ways. I can either say group by the first column or group by the column titled disciplines, and those would be the same thing. So an equivalent thing that I could have written here is group by disciplines. I'll run that. That pops out exactly the same. All right, so one is sort of a shorthand to mean group by whatever the first thing was in my select statement, one being first thing in my select statement. If you're going to do multiple things, if you're in a situation where you're grouping by multiple things, it is better to spell out the column names. If you're grouping, like we were grouping last time by season, comma, episode, right? It's good to spell that out. If you're doing just one column, you can do group by one. It's a little bit of a shortcut. All right. How are we feeling? Feeling okay? A lot of information. All right, good. Okay, so we skipped ahead a tiny bit to our task number 3. All right. What percentage of athletes earned our medals? We've done that here by just adding our disciplines. You can make a copy of your cell if you want, so you can copy that query down. All we did is we removed our line that was filtering to just rowers, and then we added a grouping by disciplines, which is that row that tells us, or the column that tells us about our sport. All right. So now that we have that, I'm going to have you take this query, excuse me, which hopefully you have, or have your own copy. And the next thing we want to find out is what sport has the lowest percentage of medal winners. All right, so we want to take these results, this query, and add one more component that's going to order these by percent medalists. All right, so we want to add something to this query that would order by our percentage of medalists. Right, remember that when you're adding components to a query, they always got to go in the same order. All right, so if you're going to add an order by, which I would suggest you do for this, it's going to need to come after your group by. Okay. We could also add a limit if we just want to find that number 1. We could apply our ordering, and then we could limit our query to just 1 or 5, which would grab the first 5 based on how we've ordered it. Okay, who's got their queries sorted? Anyone added their sort? Give me a little wave if you got your sort working, just so I know where people are at. Wait one more minute. All right, so what you should have added in here now, so we have our same query as before, but we've added our disciplines, comma at the top, and our group by disciplines or group by one at the bottom. All we need to add to answer our question, who has the lowest percentage of medal winners? We're gonna add our order by, and we're going to order by our percent medalists. All right. Hopefully I spelled that correctly. Probably be smarter to just paste it back down here. Give that a quick run. All right. Probably one other thing I should do in this query now that I'm no longer filtering by rowers is update my little alias, right? Since my alias was rowers, it no longer makes sense. So maybe I'll just change it to something like athletes, competitors, something like that. All right, and I think I gotta do one more thing, which is change my other reference to rowers, since I had rowers here in my percentage as well. All right, so just a little labeling update that I'm doing to make it make sense now that I'm no longer filtering by rowers. Okay, and now I'm sorting by percent medalists. I could also add a limit if I wanted to limit to my top 5 or so, or however many I wanted. Okay, and now I can kind of see my percent medalists. Looks like there's a couple sports where there are 0% medalists. Let's take a look. Disciplines, athletics and equestrian. All right, there were only 2 athletes in this one athlete doing equestrian, and none of them earned a medal. So that doesn't totally pass the gut check, right? That doesn't seem right. There's no Olympic sport with just one entrant. So this is where I might sort of look at my data a little bit to understand if there's some sort of data quality problem going on. In this case, it's not too hard to spot. If I scroll down, I see equestrian listed again. It looks like it's just like spelled a little differently here, right? So here it's bracket quote equestrian quote bracket, right? And up here, for some reason, on this one row, it was missing those little quote marks. So it's not being grouped together. So this one athlete, for some reason, is not being counted along with the other 246 equestrian athletes. Okay. Which is a data quality problem that we would want to clean up, right? If somebody asks us what percent of equestrian competitors won, we would want to have an accurate number, and we don't right now because of this essentially typo. So the next piece of data modeling work that we're going to do is clean that up. All right, so we're going to clean up those first 2 disciplines so that their spelling matches how they're spelled for the other athletes. So our first discipline here is athletics. Our second discipline here is equestrian. These are both just missing those quotes, so they're sort of misspelled. We want to correct the spelling so that they're counted in their correct category. Okay. We're going to use a case statement for that. All right. It's a little reminder of how our case statement is structured. The case we're going to be looking for is when the discipline is spelled like this, make the discipline spelled like this. Okay, otherwise we just want discipline. All right, so that is our task for this next part. So I'm going to let you all start with this. What I would suggest is to take your data frame from this previous one and give it a name, give it something like medalists by sport, some sort of name that makes sense. In the little green underneath your cell where you did that query, you can just double click and change the name. And then in your query down here for this task, you can select whatever, I'll let you fill that in from that data frame from medalist by sport, that same thing, I just named it. Now I'm selecting from there and just doing a little bit more cleanup. All right. So you should start with something like this. I'm going to give you a moment to think about what columns you might need and take a stab at what you think your case statement might be. Okay. How would we get those names cleaned up so that they're spelled more consistently? Totally stuck? Give me a little wave and I'll come help. All right, how we doing? Anybody feel like they got it? Anybody getting an error message? I think I saw at least a few error messages, right? So let's work through this one together. So as a reminder, my starting point is I had my result from our last query, right? My result from up here. Get rid of my limit. All right, so I have my query from here and I just gave it a name. I gave it something I could reference. In this case, it's medalist by sport. So for this query, I'm just starting with selecting from that data set. All right, I've already done some cleanup. So I gave my last query a name in this little green spot on the bottom of my cell. And then from down here, that's going to be in my from. That's my new table that I've selected from. I can actually see it in my data browser right here, medalist by sport. It has 52 rows because it pulled up 52 different disciplines. Okay. All right. So next thing I want to figure out is what result do I want to end up with? I basically want to end up with the same columns that I had before, but I just want to do this cleanup task. All right. So all I'm going to do here is I'm going to list out my columns. I want all of them. I want my disciplines. It's going to help me do some autocomplete. I want all my athletes. I want my number of medalists, and I want my percent medalists. All right, so I'm going to start with this. Okay. Now I need to do a little bit of cleaning up of my disciplines column, right? Because I have essentially some of these typos or data quality problems. So I'm going to add a case statement for my disciplines, right? So basically what that means is I'm going to select, fill in a case statement here, where I'm going to do some manipulation of my disciplines column. And then I'm going to rename that column to be disciplines. All right, so I'm essentially going to do a little manipulation of it and then sort of replace that new version so that I have, my results will look very much the same, but my rows will be a little different. My columns will be the same. My rows will be a little different. Okay. So what are my cases that I'm worried about? I'm worried about the case where equestrian is spelled like this instead of like this. So first thing I'm going to do is write that condition. All right, so when my disciplines is equal to this way that it's spelled, equal to this. And since this is a string, a piece of text, I need to put it in my quotes, right? My single quotes. So this is my when condition. So when it is spelled like that, I want it to be spelled like this, right? That's all I'm doing here. So when it's spelled like that, I want it to be spelled, since this is getting a little longer, I'm just going to separate it onto a new line here. Then I want it to be this value. So I could go copy paste it from up here. Equestrian, right here. All right, so I want it to be spelled like this. I'm just going to copy that so I have the exact spelling. Come down here, and as a reminder, it's got to go in single quotes because it's a piece of text. All right, so I'm going to do single quotes, and I'm going to paste in my text. Now this looks a little funky. The like pink and white highlighting like looks a little off because it's always going to highlight a string as all pink. All right, now I can see that because my string, which is denoted with single quotes, actually contains single quotes. It's sort of like self-imploding in the middle here, right? It's treating this as a little string and this is a little string and not my whole thing. All I need to do to fix that is add an extra single quote in front of the ones that I want to be inside. What does that mean? I'm basically going to add a little single quote where there's just one, and a single quote where there's just one. And that'll sort of signal to SQL that it should treat the whole thing as, I got an extra one in there, the whole thing as a string. I can tell if I did it right if the whole thing is pink. All right, so it should be single quote bracket, single quote, equestrian, and then the reverse. All right, single quote, bracket, single quote. All right, that's what the second hint was trying to tell you about, putting that extra little quote to make that work. All right. So what am I doing? I'm taking the case when that disciplines column is sort of misspelled. I want to correct that spelling. Otherwise, so else, this is a component that we didn't include in our previous case statement. What do I want to do in the case when the discipline is not specifically this? I just want to grab the discipline as it is, right? All the other ones are fine, except for this one with my typo. So if I can spell this, disciplines. So in this specific case, I want to actually replace it with this. Otherwise, grab what it was before. Okay. And we're gonna see if that runs, see if I made any typos. Okay, fabulous. Now I see that my discipline here is corrected. It's still just listing one athlete. I'll get to that in 1 second. Still just listing one athlete, but it's now spelled the same as this guy. Now, why did these not combine into one line? Because all I've done is just rename it. I now need to regroup it because I did the grouping before it had the same name, right? I did the grouping back up here in this other cell. I'm not grouping it again here, so it's not grouping together yet, right? If I want them to group together, I need to add one more thing, which is basically my the same sort of math that I did before. One sort of easy way to do that might be, I could just take my whole query that I did before and replace this disciplines with my sort of case statement disciplines that I just wrote out. All right, so what would that look like if I took my whole query like this, bring it down to here. All right, and I'm just gonna take this first disciplines bit and essentially replace it. I'm gonna delete this guy. So this part is all the same from up above, and all I've done here is replaced my disciplines part. All right. Mess anything up with my copy paste, and that should do my, gotta rename my title. All right, disciplines clean. I think that's the last bit I missed. Beautiful. Okay, great. So when we've combined these, we've gone down from 52 to 51 rows. Why did that work? Because we've done our little cleanup logic, right? We checked for this typo, we replaced it with the correct spelling. Otherwise, we grabbed that existing value. We gave the column a new name. I should have given it like a slightly different name so that I can distinguish down here when I'm doing my group by. So I named this disciplines clean. I could have named it sport or something else. All right, disciplines clean. And then I'm doing my group by with this cleaned up, disciplines clean, this cleaned up column. And that's going to group my equestrian athlete that wasn't counted. Right before this was 246 and my other one was in a different row. Now I see I've got my 247. So now when it's getting this percentage, it should be accurate, right? The big enough number, it's probably just a decimal place or so, but it's accurate. Okay, now I had one more row in here that was a little bit of a typo, this athletics one. All right, I see down here that there's actually 2,000 athletes that are in athletics, but it's sort of the same typo, right? It's just missing those quotes. So I kind of want to do the same fix for this one. The good news with my case statement is that I can add multiple pairs of when then logic in the same case statement. So what does that mean? I have case when this thing, do this thing, else what do you grab in the other case? All right, I can just take my when then and I can have as many when thens as I want. All right, so in this case, I'm going to add another pair of when thens and I'm just going to swap in my values for this athletics one. All right, so I'm going to check for the equestrian case, fix the typo, check for the athletics case, fix the typo, and I'm doing that in the same line. Okay. So here I'm just going to grab this one, my sort of typoed version, and replace that in my second when. All right, so I'm just going to paste that in. And then I just need to make sort of the same correction in that second then. So I'll just make sure that this says athletics, but with those little quotes added in. Okay, go down here and double check that that's how it's spelled. Looks promising. All right, give that a second to think. All right, great. And now it's disappeared off the top in my sort, which is a good sign. My number of rows went from 51 down to 50. Also a good sign that my row got combined. And then if I go down, I see that athletics here went from 2057 to 2058. All right, so I'm doing all my just mental checks to make sure that worked how I thought it worked. Awesome. Yeah, question.
Is there a way to like make it so that it's like a variable instead of like you just have to like re-paste it every time?
So in this particular case, since I'm fixing some sort of specific typos, I've got my string. We can do a little bit more sort of advanced, adding some variables into SQL. In particular, we can do that with hex. We may get a little bit into that week after next, but yeah, you can essentially sort of replace this with like some extra brackets, fill in a variable there that you're setting somewhere else. But slightly beyond the scope for today. Okay. Any questions about how we got sort of down to our 50 more cleaned up rows from our 52 rows with a typo? Any questions about what we're doing here? Okay, again, why are we doing this? This kind of seems like a lot of work. This is another example of the type of thing we would do in our data modeling cleanup, right? If we can produce this nice clean table, all the sports, all the typos fixed, all our percentages already figured out, this is much easier to hand to, say, a journalist or to pull a quick data point from for someone who wants to know, maybe a reporter, right? To just pull this from here when it's all ready and we don't have to worry about fixing typos in response to an individual request, okay? This type of data modeling sort of cleanup thing is also great if you are using any sort of like ChatGPT or any of those similar tools. Some of them are built into Hex. You're welcome to mess around with them a little bit. It's called Hex Magic is how they used to brand it. I think they might have rebranded it. But one thing you want to do sort of ahead of asking AI to do a lot of querying for you is to just be doing any sort of like initial cleanup or sort of things that you need to know a little bit of context to clean up. In this case, that these are the same sport. AI may or may not catch that depending on sort of the context that you're setting. But these are the sorts of like cleanup steps that are good to do before you hand your data either to another human or if you're going to be using any sort of assistant with it. All right. Okay, cool. Great. So we have talked a little bit about these functions. We've talked about our case statement. We've talked about left join and join. We have talked about how to do joining with using the column name. So that's if it's spelled the same. And join with on column name equals other column name. That's what we do if our column names are different, but they're the same piece of information we want to join. And then we did some comparing of text or strings using this I like, and then using these percent signs, which are going to indicate our that our text can be found anywhere in that string. All right. So let's get a couple more queries going. I don't think we're going to have time to get all the way through our volleyball sort of portion of the agenda tonight, but why don't we do a couple more queries? Go ahead and take a look at our teams data set, which is here, our teams data, our volleyball results and our rowing results. All right, so go ahead and get the first 10 rows of those tables. Take a look and we'll kind of talk through some of the rest if we don't have a chance to get all the way through. But go ahead and grab those first 10 rows of those data sets. All right, so hopefully you have something like this, select star from your data frame, limit 10. All right, we're looking at our teams data, our rowing results, our volleyball results. All right, so our next sort of prompt question is to figure out of all the results, which country competed in the most races and how many athletes total competed on those teams. All right, if you aren't familiar, rowing is a sport that can happen either individually or in boats of 4 or 8 people. So teams are potentially going to have multiple people, or it may just have 1 or 2 depending on the event. So we want to be able to figure that out. So in order to answer that question, we're going to need to combine data from our rowing results and from our teams data. So we would follow the same workflow here, our same kind of mental checklist that we ran through for this example. All right, so what tables have the columns that we need? Does each table have 1 row per entity? All right, so to get to our rows per entity, we want to think about whether we need to condense. So in this case, to answer our question, which is here, which country is what our question is about. So our entity should be by country, right? What we want to do is think about how many races did each country participate in and how many athletes total competed on those teams from that country. All right, so we get that's sort of the entity level that we're thinking about for this question. Do we want all the rows that appear only in both tables or from, so essentially do we want to join or do we want all the rows from one table and augment any information where we have it? All right, that would be our left join. That's what we did before with our medalists and our athletes. Okay, so in this case, we're going to have a bunch of information about each rowing race, and then we're going to have a bunch of information about teams. Now, in this case, this is going to have teams that are not just rowing, right? But this data set only has our rowing results. So here we probably want to include any row that's in our rowing results data and sort of augment team information onto it. All right, so we're going to sort of use our left-hand one where we want all the rows is our rowing results. Hopefully all those teams also exist in our team data set. All right, so we're going to join those together. All right. Next thing to look at in our checklist is what would we join on? What column has a unique identifier? All right, so in this case, we're going to want to look at our columns, same as we did before, and we're looking for some sort of identifier. All right, so again, your data might come with documentation. Often it does not. So what you're going to need to do is sort of look across and try to figure out something that might make sense. So I'm going to take a look at my teams data and I'm going to take a look at my rowing results data. All right. So thinking again, I'm going to need some sort of identifier where I can match my rows across my 2 data sets here. Again, I'm sort of looking for some sort of pattern, right? I'm trying to kind of pattern match on what would be a good ID to use. In this case, where to go? Here it is. So I have this participant code column, which is sort of an odd, it's like some text and some numbers. Okay, this is row M, skull 2, and then it's got some more letters and numbers following. Up here in my teams data, I have this column, which is in sort of a similar format. All right, so it's got some like information about the sport event, it's got a number, it's got a dash or multiple dashes, and then it's got some more letters and numbers that look like there's some sort of country code, right? Great Britain is GBR, India is IND, Italy is ITA, right? So this is some sort of code that's referencing the sort of sport and the country. This is some sort of code that's representing the sport and the country. So this is the going to be our ID that we're going to use. If I look a little bit more closely, if I scroll down to more examples of this, I'll see some matching values here in my participant code column that would match to my code column in my teams data set. All right, so that's the kind of pattern I'm looking for. That's the step in my checklist here where I'm looking for what value would I actually use to match across my tables. That's what I would use. All right, and then the very last thing would be thinking through what I want to end up with. All right, in this case, I'm going to want some results that have for each country, how many races did they participate in? So how many times does that country appear in that results data set? There'll be a count star for my results data set, right? And then how many athletes competed on those teams? So once I've matched on my participant code, I would want to do a count star from my teams data set, which should get me my number of teams. I'm sorry, a minute. So sorry, that's my teams. Here I have my column for number of athletes. So I'd want to add this up, right? So if I've got 3 teams from India down here, and then I'd come up to this table and see that each of those teams has 8 people. Maybe they've entered 3 votes of 8 in the competition. I would be able to sum my number of athletes. So instead of doing a count, I would do a sum summary to get 24. So my results for this question would look something like a column for country, a column for number of races, and a column for number of athletes. All right, that's sort of the checklist that I would go to for this. So you have all the data sets that you would need to answer this question. They're here, and this query is actually fairly similar to the one that we just worked through. So we are out of time, but if you wanted to do this as a little bit of practice, there's this one, and there's a few more further down as well. You have all the information to do these, and these all use all the same functions that we just went through. All right, so if you have a little bit of extra time, you really want to get into the SQL, sort of reinforce what we covered today, I would encourage you to go through and do the last few examples in here. All right. All right, that said, we are just about at time, so I will save this little bit for later. But I did want to remind you all that we have 3 more sessions of this series. So next week, we're going to sort of put all of this stuff on the back burner and sort of start fresh with Python, which is sort of a multi-purpose programming language, but has a lot of use cases for analytics specifically. So we'll be specifically focused on how to use some of the analysis features. So we will not be building a website or writing an app or anything like that. But we will be doing sort of very similar to what we just did in SQL. I'll show you how to do that in Python, and then we can sort of add some additional layers with Python that are pretty cool. So we'll get into that next week. We'll get a little bit deeper into Python the following week. And then week 5 is going to be where we do that sort of portfolio project that I mentioned, where we bring all this together. So if you want to come in week 5, I highly encourage you to come the next couple weeks as well, so you can kind of put all of this together. The slides and stuff and this recording will get posted to the Digital Lounge website, the annabergdl.org website. So you'll get these links. I think I also might have linked them on the little site where you grabbed the link at the beginning. But these are just some little articles and more kind of learning stuff if you want to get more familiar with SQL. I specifically really like this murder mystery one because it's a little more fun than the average internet tutor. All right. That's all I got. We covered a lot of stuff today. If your brain's feeling a little tired, that's okay. But you have a copy of your worksheet. You have access to Hex, I think, for like, I don't know, 6 or 12 months after this session. It's free from them for this workshop. So you can go back to that. You have access to it. So you can poke around back there if you need a little refresher. I'll hang around for like 5 more minutes or so if people have questions or you hit any errors or anything. I'm happy to help. Thanks, everybody. See you next week.